Hi guys, welcome back for week 5. I can't believe it, it's already week 5 of learning from home. You guys have a slightly shorter week this week because today, being Monday the 13th, is technically part of our spring break. So if we were still in school, we would not have had school today. So I'm not counting this as a work day for you guys to do. You don't have to do your notes or assignment today. I'm just filming it today so that I could post it tomorrow. But that just means you have one less day to get your notes and work done. So I'll try to keep the homework short because I still want you to submit that by Friday. And then I'll post answer keys then. And if you want to talk to me on Google Hangout, you can, and ask questions about this stuff from week 5. Or if you just want to talk about something else, that's fine too. But this is going to be our week 5 topic. So we're still in the factoring in polynomials unit. We're just going to talk about what a difference of squares is. So again, week 5, make sure you submit your notes and your homework to me by Friday. Speaking of answer keys, I did just post today the answer key for last week's homework, which was week 4. So those of you that got your homework to me, make sure you check out that answer key on Google Classroom and see how you did. And you can always still ask me questions about the stuff from last week. Just because that week's over doesn't mean you can't ask about it. I know we kind of got thrown off a little bit because last Friday was also part of our spring break, so we wouldn't have had class either. So again, make sure you get your homework and notes to me. And those of you that did do your homework for last week, thank you for getting that to me. And just check what you have with your answer key that I just posted today. Okay, so I'm going to skip what's above here, which is just some warm-up questions to get us to this topic of the difference of squares. So what is a difference of squares? Well, the difference is referring to what we call the answer to a subtraction problem the difference, just like a sum is the answer to an addition problem. So the difference means we're going to be doing subtraction. Difference of squares means that you can square root both terms in the polynomial. Okay, so in order to factor a difference of squares and follow this rule, you have to first make sure that you actually have a difference of squares, meaning there must be a subtraction sign, and you can take the square root of both terms evenly. So we wouldn't be able to take the square root of a 5. So if the second term in this polynomial was a 5, well, we wouldn't have a difference of squares because we couldn't take the square root of that and get a whole number. So here's what we do. Once you realize you have a true difference of squares, you just use the following rule to factor that out. Okay, so last week what we did is we factored using the greatest common factor. This is going to be a rule to follow if your polynomial looks like this. So subtraction sign in the middle, and you can take the square root of both of the terms. Okay, so when you're factoring a difference of squares, all you do is you split that up into an addition, set of parentheses, and a subtraction. So you're going to take those two square roots, you're going to add them in the first term, and subtract them in the second term. Now, what you could always do to check your work is just distribute everything using FOIL. All right, so multiply the first terms, multiply the outside, multiply the inside, multiply the last. You can still check your work by basically multiplying everything out again, and you should get back what you started. But if you have a difference of squares, this is how you would set up your answer to factor it out every single time. So our directions here for the examples we're doing, I've circled them already because I'm not going to go through each one. A lot of them are alike. It says to factor each difference of squares. Check your work by distributing if you want to. And if a polynomial can't be factored, just write prime. So we had a couple examples like that last week, and it basically just means that you can't factor that polynomial at all. You can't use the difference of squares. You're just going to leave it exactly how it is. So first thing we got to do, number 1, this says a squared minus 4. Well, do we have a difference of squares? Do we have subtraction sign? Yes. Can you take the square root of both terms? Yes. Okay, the square root of a squared is 4. The square root of 4 is 2. So to factor this out, we're going to write 2 sets of parentheses. And the first set is going to have addition. The second set is going to have subtraction. So how would we get a squared? Well, all you would do is take a times a. Because remember, when you're multiplying with exponents, this would be a to the first and a to the first. Well, it would get you a squared because you add the exponents when you're multiplying, okay? Well, what's the square root of 4? It's 2. So that means the second part of each of these sets of parentheses is just going to be a 2. And this is your answer. Okay, you just take the square root of your two terms. First set of parentheses has a plus sign. The second set has a minus sign. And that is it. Okay, so let's move on to number 2. We have a difference of squares because there's a subtraction sign, and we can take the square root of both of those, n squared and 64. So 2 sets of parentheses, plus sign, minus sign. The square root of n squared, or what would you get? What would you have to multiply together to get n squared? Well, you would multiply n times n. What's the square root of 64? It's 8. So you write that in the second spot in both sets of parentheses. And this is that original term, or that polynomial, factored out. Okay, so I have number 5 circled next. So let me move down my paper. Okay, k squared plus 25. Well, let's check. Do we have an actual difference of squares? Well, I can tell right away by looking at this that we don't, because there's an addition sign. You have to have a subtraction sign in order to use this rule to factor out a difference of squares. So this is going to be prime because we don't have a difference of squares. Now, what a lot of you are thinking, maybe, is that, well, you can take the square root of 25 and get 5. You can take the square root of k squared, and get k. Well, yeah, that's true, but in order to factor it out like this into our 2 sets of parentheses, what we would end up with is k plus 5 and k minus 5. But if you do that, you would not, if you checked your work and distributed using FOIL, you would not get your original polynomial of k squared plus 25. Because in this case, you're going to be multiplying 5 times k, negative 5 times k, and you're not going to end up with plus 25, okay? So this is just going to be prime because we can't get back what we started using difference of squares. However, in number 6, we do have a difference of squares. But the reason I wanted to do number 6 is because now the term with the letter and the number, the variable, is at the end. Okay, the squared is at the end instead of at the beginning like in 1, 2, and 3, 4. Actually, not 3, but 4 and 5. We can, however, take the square root of 1. And we can take the square root of 49y squared. There's a subtraction sign, so we're good to go. Set up your 2 sets of parentheses. Plus sign, minus sign. Well, what's the square root of 1? That's easy, that's just 1. What's the square root of 49y squared? Well, what would you multiply together to get 49y squared? Well, it would be a 7 and a y. Okay, square root of 49 is 7. Square root of y squared is just y to the first. So this is factored out. That one's done. Let's do number 7. Okay, can we factor this out using the difference of squares? Subtraction sign. Can we take the square root of both? Yes, we can. So go ahead and set these 2 up. Okay, plus sign, minus sign. Well, what's the square root of 9b squared? Well, the square root of 9 is 3. The square root of b squared is just b. And then the last one's easy. Square root of 100 is 10. Okay, so 3b plus 10 times 3b minus 10. And the last ones I have on here are 11 and 12. Okay, can we do difference of squares? Yes, we can, because we have subtraction and we can square root both of these terms. Same setup. 2 sets of parentheses, addition, and subtraction. So let's look at this first term. Well, what's the square root of 4h squared? What would you multiply times itself to get this right here? Well, to get a 4, you would do 2 times 2. To get h squared, you would multiply h times h. So 2h times 2h gets you 4h squared. Now what about 25g squared? Well, the square root of 25 is 5. The square root of g squared is just g. So we're writing 5g and 5g. So let's do number 12. We can do difference of squares because we have subtraction, and then we have, yep, two terms that we can take the square root of. Now 64u squared, square root of 64 is 8. Oops, here's my plus and my minus. Square root of u squared is just u. So we're going to write 8u at the beginning of both of these parentheses. Now v squared is just the result of doing v times v. And number 12 is done. So I'm going to switch out my papers and do two more examples. If you're good to go on how to do these, you can skip these last two, but I'm just going to do two more. They're not that different, just maybe slightly, but 15 is just another example of a prime question because we have a subtraction. We have the difference symbol, but we can't take the square root of both of these terms. 4c squared, well, yeah, you could do 2c times 2c, but we can't take the square root of 5. For d squared, you could do d times d. Square root of 5 is going to give you a decimal, so we can't get a nice even whole number for that. So that one would just have the answer prime. Now for 16, you do have the difference of squares. Even though the exponents of 4, the square root of 4 is 2. So to set up your two sets of parentheses for a problem like number 16, well, what would you have to multiply? Here's my plus, my minus. Don't forget that. What would you multiply times itself to get this right here? Well, look at each part individually. Square root of 49 is 7. The square root of m to the fourth is m to the second. So let me write this down and I'll show you why. 7m squared. Again, when you multiply, if you were to write this all out and check your work by multiplying, if you multiply m squared times m squared, when you're multiplying with exponents, you add the exponents. So 2 plus 2 would get you the 4. 7 times 7 would get you 49. Now the second part's easy. You're just taking the square root of 16, which is 4. So your answer is 7m squared plus 4 times 7m squared minus 4. Okay, so these are all the examples we're going to do with difference of squares. Next week is not going to be too different. It's still going to be difference of squares, but just with factoring out the greatest common factor. So I'll post your assignment along with this video, and just make sure you get those to me, please, by Friday. And you can check your answer key then too. Try not to wait until the next week to get me your notes and your assignment, because then that just makes you fall a little bit more behind, and you don't want to get weeks and weeks behind on our schoolwork. So get those to me by Friday, submit them to Google Classroom, email them to me, or send them to me via Remind. And then please reach out if you have any questions.